Hey everyone, here's our math problem for today. Let's begin with this regular hexagon, a polygon with 6 equal sides. And let's call this as hexagon A, B, C, D, E, F. Then let's extend side DE in the direction of E, and we form this red line segment GE. Then let's connect each of these 2 points, G and E, to this vertex B this way. And let's call the point of intersection here as point H. It is given that the measure of angle ABH is equal to 45 degrees and the length of segment HE is 2 units. Now the question is, what is the length of segment FH? You can pause the video and see if you can solve this interesting geometry problem. Now let's solve this problem together. Let's recall the formula to find the sum of all the interior angles of a polygon. The formula is the number of sides minus 2 times 180 degrees. For our hexagon here, there are 6 sides. So our n is 6 minus 2, that is equal to 4, times 180 degrees. And we have 720 degrees for the total of all the interior angles of this hexagon. Now, since all the angles of a hexagon are equal, then we can find the measure of each angle by dividing this 720 by 6 to get 120 degrees for the measure of each of the interior angles of our polygon. So it's 120 degrees here, 120 degrees here, and all the other vertex angles. Also, since our polygon is regular, that means all the sides are equal. At this point, let's focus first on these 2 equal sides, these 2 equal angles, and we have here an isosceles trapezoid, which implies that the base angles, angle CBE and angle DEB, are also congruent. Now, using the sum of the angles formula again, in this isosceles trapezoid, our n is 4 because a trapezoid is a polygon with 4 sides. So n minus 2 becomes 4 minus 2, or 2, copy 180. So the sum of all the angles of this quadrilateral is 360 degrees. We already know the measure of this angle and the measure of this angle. And these 2 angles here, the base angles, are equal. And the sum of these 4 angles is 360 degrees. Therefore, to find the measure of angle BED, we can compute for it by subtracting the sum of 120 and 120, which is 240, from 360 degrees, and then divide it by 2 to arrive at angle BED equals 60 degrees, the same with angle CBE because these 2 angles are equal. Now, we can now find the measure of this small angle here because this angle ABC of this regular hexagon is 120 degrees, the same with this angle, and the same with all the other interior angles. Then, to find this angle, we just need to subtract the sum of 45 plus 60 from 120, and that will give us 15 degrees. 45 plus 15 plus 60, that is 120 degrees. Then, angle GEB and angle DEB form a linear pair. That means we can now find the measure of angle GEB by just subtracting 60 degrees from 180 degrees to arrive at 120 degrees. Then, we can now find the measure of this angle by subtracting the sum of 15 and 120 degrees from 180 degrees to arrive at 45 degrees. So this angle here is 45 degrees. Now we know that this angle of a regular hexagon is 120 degrees. We already know that this is 60. That means this small angle here must be 60 degrees also. And therefore, the other angle here is also 60. So that 60 plus 60 plus 60 is 180 degrees, which is the measure of a straight angle. Because of that, we can now find the measure of this angle here. That angle is equal to 105, so that 105 plus 60 plus 15, that gives us 180 degrees, which is the sum of all the interior angles of a triangle. Let's construct this triangle AFB. What do we know about this triangle? We know that this side and this side are equal because our hexagon is a regular hexagon. Also, we know that this angle here is equal to this angle, equal to this angle, and all the other interior angles of the regular hexagon that is also equal to 120 degrees. So we have here an isosceles triangle, which means that this base angle here and the other base angle here must be equal. This 45 degrees is the measure of this bigger angle here. So how can we know what is the measure of this base angle? Knowing that this angle here is 120 degrees. What we are going to do is subtract this 120 degrees from the sum of the three angles of a triangle, which is 180. That will give us the remaining angles, this angle and this angle here. But since these two base angles are equal, we can divide the result by 2 to arrive at the measure of each of these base angles, and that gives us 30 degrees here, and this 45 degrees must be split into 30 and 15, so that we now have this isosceles triangle with a measure of 120 degrees for this angle and 30 degrees each for the two base angles. Then one more angle here, this angle FHB and this angle here BHE form a linear pair, which means that their sum is 180 degrees. So this angle here is 75 degrees. Then, since this is 75, this is 15, then the measure of this angle must be 90 degrees, so that 90 plus 75 plus 15 is 180 degrees, which is the sum of the measures of the three interior angles of a triangle. At this point, we already know most of the measures of the angles that we need. But what we want to find out is the length of side FH. And there is only one given measure for the side, which is these 2 units. So how can we jump from these 2 units to find the measure of side FH? Well, we need to find first the measure of segment HB. And let's call it as X. So let X be the length of segment HB, and we can now use the law of sines. For the law of sines, consider this triangle HBE. You take one measure of the side and its opposite angle, which is this angle, you form a ratio. We have here X over sine of this 60 equals, since we already know the measure of this side to be 2 units, then we need this opposite angle. So we form the ratio 2 over sine of 15 degrees. Then let's solve this equation for X. Multiply both sides by sine of 60 degrees to arrive at X equals 2 sine of 60 degrees over sine of 15 degrees. Let's put this aside because we are going to use that value later on. Now this time, let's go now to this triangle FBH. Again, let's use the law of sines. We know the measure of X to be this value, and we get the sine of 90 degrees. So we now have X over sine of 90 equals, the length of the side that we want to find is FH over the sine of its opposite angle, which is this angle, sine of 15 degrees. Solving now for FH, we multiply both sides of the equation by sine of 15, and here is the result. This X, remember, is this value here, so we can now substitute the value of X to that equation to arrive at this. So this X is this part here, and we copy all the rest. Notice now that this sine of 15 and this sine of 15 will cancel each other out, and the sine of 90 degrees is equal to 1. So basically what's left is FH is equal to 2 sine of 60 degrees. And we know that the sine of 60 degrees is equal to square root of 3 over 2. And so 2 divided by 2, that is equal to 1. We now have the value of FH to be equal to square root of 3, and that is now our final answer. So the length of segment FH is square root of 3, and that is where the math is. Thank you very much. This is Lando Assistant, and we hope to see you again in our next video.